Day 7. In today's lesson, we will learn how to simplify and evaluate expressions that involve fractional exponents. At no time will we be allowed to use our beloved TI-30XS multiview, sadly. You may see me use it, but if you do, it'll be only to use the 4 functions: add, subtract, multiply, and divide, because that's all you will be allowed to use on your next test or quiz involving this material, a 4-function calculator. Keep that in mind. All right, let's look at problem number 1. Notice that the bases are the same. When the bases are the same, you can when you multiply, you add the exponents, all right? It's just like we learned that, for example, if we do x to the 4th power times x to the 5th power, what is this? We learned that this would be x to the 9th power. You add the exponents. Well, it works the same even if the bases are numbers instead of variables. Still, when you multiply, you add the exponents. Notice you do not multiply 3 times 3. We will not get 9. We will simply have 3 to the 5 over 3 plus 1 over 3 power. Now, I will expect you to do this in your head. 5 over 3 plus 1 over 3. 5 thirds plus 1 third is 6 thirds. Okay? When you add fractions, you just, if you have like denominators, which you must have, you just add the numerator. So 5 thirds plus 1 third is 6 thirds. But obviously we will reduce this. So this would be 3 to the 2nd power, all right, 3 squared, which of course is 9. So the final value for problem number 1 would be 9. All right, let's look at problem number 2. We learned, for example, if we had x to the 10th power divided by x to the 2nd power, what would this be? We learned that this would be x to the 8th power because we can subtract. When you divide with exponents, you subtract 10 minus 2 is 8. Or we could look at it as canceling. But for this, for what we're doing now, we really need to look at this as 10 minus 2. Okay, so we will do the same thing now. Since the bases are the same, to divide we will subtract these exponents. So this will be the same thing as 7 to the 1/5 minus 3/5 power. Okay? Now, you know that 1 minus 3 is negative 2. So this will become quickly 1/5 minus 3/5 is negative 2/5. Now, don't forget what we learned before. If we have a negative power, we're going to have to drop this down to the other side of the fraction line. So there's an invisible fraction here. So this entire expression, because it has a negative exponent, is going to drop below. So that's why we're going to wind up with 1 over 7 to the 2/5 power. All right, so you can just leave that as your final answer. All right, let's take a good hard look at number 3. Now, on the previous problems, the bases were the same. Bam, bam, both 7. Ba-bam, both 3. The bases were the same. And when the bases were the same, we were able to work with the exponents. In this case, we added, and in a division problem, we subtracted. But the bases were the same. Now, when you look at number 3, the bases are not the same. But something is the same. Can you see what it is? The exponents are the same. So, this is a different kind of problem. It turns out that if the exponents are the same, you can work with the bases and do the operation that you're thinking about doing. So, look, if I want to multiply these together, I can, if the exponents are the same. Because basically, what's really happening is, it's like taking out the 1/4 power from each one and leaving behind 4 times 64 and then doing the 1/4 power. Because you know that if I had two things multiplied together, I could take this 1/4 power and apply it to each. Well, this is sort of the reverse of that. Alright, it's like I'm taking that 1/4 power away and putting it outside of the parentheses. So this is legal. So 4 times 64, what is that about? Alright, even on a 4-function calculator, we could quickly find the 256. Okay, so that means what we have here is 256 to the 1/4 power. Now, hopefully you have learned that 1/4 power is the same thing as the 4th root. Okay? When you have a fractional exponent, it is in the form power over root. And so this 4 is the root. So this is the 4th root of 256. So we will use our table to evaluate that. If I want to evaluate the 4th root of 256, because the 4th root, I start in the 4th power column, and I look for the 256, and the root will be this n on the far left. So the 4th root of 256 is 4. So the final answer for problem number 3 is, in fact, 4. Okay. Okay, let's go on to number 4. Oh, look, what do we have here? A negative exponent. Now, hopefully you have not forgotten that when you have a negative exponent, that means this expression is on the wrong side of the fraction, and it must be moved. So it's going to come up and become a positive exponent. So up in the top, this will become 36 to the positive 1/2 power. Okay? Now, there's different ways I can do this, but I need you to understand that 1/2 power is the same thing as square root, because this is the fastest way to do this, and I need you to be comfortable with this. So you should immediately know, even without rewriting it, that this is going to be simply 6. Alright, so look, 1/2 power is the same thing as square root. Now, as long as we're on the subject, okay, so look, let's practice that for a second. So what would 49 to the 1/2 power be? That would be 7. Okay, can you tell me what 144 to the 1/2 power would be? That would be 12, okay, because it's just taking the square root. Now, please understand that if I did the 1/3 power, let me just erase this mess. Alright, for example, if I had 27 to the 1/3 power, the 1/3 power is the same thing as the cube root. Alright, and the cube root of 27 is 3. Right? See the 27? The cube root of 27 is 3. Okay, so for example, let's say I had 216 to the 1/3 power. That would be the same thing as the cube root of 216. Alright, the cube root of 216 is 6. So this would be 6. And it keeps going like that. 1/2 power is square root. 1/3 power is cube root. Can you guess what the 1/4 power would be? That's right, it would be the 4th root, which I believe is 2. 4th root 16, 2 is 2. Okay, so go ahead and own that. 1/2 power is the square root, 1/3 power is the cube root, 1/4 power is the 4th root, and so on. So anyway, the answer to number 4 was 6, and that's the best way to handle it. All right, number 5. The bases are already the same, so we can go ahead and add these exponents. So this is going to be the same thing as 2 to the 1/4 plus 1/3 power, all right, to the 6th power. Okay, so in the past we've had our TI-30 XS multiview, so I guess we need to do a little side lesson on how to add fractions that don't already have like denominators. So I think the best thing to do is just off to the side, all right, we'll make a little scratch paper over here. All right, if I want to do 1/4 plus 1/3, you have to have denominators that are the same. So we need to change these into something bigger that's the same. So 4 and 3 can both be turned into 12s. And so the way you do that, I can turn this 4 into a 12 by multiplying by 3. I'm only allowed to do that if I do it in the numerator as well. I can turn this 3 into a 12 if I multiply by 4. But I'm only allowed to do that if I multiply the numerator by 4 as well. Okay, so this will become then 3 over 12 plus 4 over 12. Now the denominators are the same, so we will add the numerators. So this will be 7 over 12. Okay, so that's how you add 1/4 plus 1/3 without a TI-30. So that's what you have to do. So on this problem, we now have 2 to the 7 over 12 power, okay, to the 6th power. So this is what we have so far. Once again, we have a power to a power. So we have to multiply. So as we saw in the other problem, if I multiply this, you know, this is like having 6 over 1. So I really am just going to multiply this straight across. So some of you would just do this. 7 times 6 is 42. Then 12 times 1 is 12. All right, then it's just a matter of reducing this. Okay, so this would give you 2 to the, let's see, if I divide these both by 2 first of all, that will give me 21 over 6. Then I have to keep going, because now both of these are divisible by 3. So if I take these and divide by 3 now, then that's going to give me 7 over 2. All right, so this is the final answer. 2 to the 7 over 2 power. That's the final answer. Now, that's the way most of you prefer to do it. Now, if you have a little bit more skill than that, then this is what you do. This is what I would do, because of course I have skills. The 6 and the 12, I would reduce them early. All right, I wouldn't multiply the 7 times 6. I would reduce the 12 and the 6 now. 6 goes into itself once, 6 goes into 12 twice, so that immediately gives me the 7 over 2 that we got. All right, doing it this way takes more time. So by just canceling the 6 with the 12 and making 2, I get the 7 over 2 right away. To me, that's easier. But some kids just can't handle that. So You decide if you can handle my way, which is quicker, or if you have to do it in steps. It's up to you. Okay, we're on number 6. Now, in the previous problems, we either had like bases, like 2 and 2, or we were able to make like bases. The exponents were different. So the bases were the same, so we worked with the exponents. Now in this problem, the bases are not the same, and we're not going to make the bases the same. But something is the same. What is the same in the numerator and the denominator? Can you see that the exponents are the same? Okay, so look, here's the rule that I want you to be comfortable with. If the bases are the same, like for example, if I have 2 to the 5/3 power over 2 to the 1/3 power, if the bases are the same, then I can go ahead and work with the exponents. So in this case, I would have done 5/3 minus 1/3, which would give me 4/3. So if the bases are the same, you can work with the exponents. Now, on the other hand, if the exponents are the same, you can work with the bases. So, since the exponents are the same, I can go ahead and work with the bases and do this division. And the reason is because, technically, this is going to be the same thing as 70 over 14 all to the 1/3 power. Okay, so if the exponents are the same, you can basically make parentheses and pull that 1/3 power outside of the parentheses. So you can do this. So 70 divided by 14. Let's work with that. So even on a 4-function calculator, which we're going to pretend, 70 divided by 14, we can see that that is 5. So this is going to be the same thing as 5 to the 1/3 power. But again, essentially, if the exponents are the same, you can go ahead and do the operation with the bases. You can do the 70 divided by 14. So this would be the final answer, all right? Not too bad. All right, let's go on to number 7. Let's start with the numerator. Look, if the bases are the same, I can do something with the exponents. So 125, 125. The bases are the same, so I can add these exponents. Now, 2/9 plus 1/9 is what I'm doing. So that's going to be 3/9, which will reduce to 1/3. And down here I have 5 to the 1/4 power. Okay, so that's going to be the same thing as 125 to the 1/3 power over 5 to the 1/4 power. That's what we have so far. Okay, again, I did 2/9 plus 1/9 when I did this. Now, we just learned that 1/3 power is the same thing as cube root. Okay, so this is the same thing as the cube root of 125. All right, the cube root of 125 is 5. So this is going to be equal to simply 5 over 5 to the 1/4 power. All right, we did the cube root, and it turned out to be 5. Now, suddenly the bases are the same. So if the bases are the same, now I can work with the exponents. Now this 5 has an invisible exponent. Do you know what it is? It's 1. It's an invisible 1 right there. It's 5 to the 1 power. So when we divide with exponents, we subtract the exponents. So since the bases are the same, I can do 5 to the 1 minus 1/4 power. Okay, so now once again, I'm going to do this off to the side. So if I want to do, all right, here's my scratch paper. If I want to do 1 minus 1/4, to me, here's the easiest thing to do. I love it when I have a 1, because I can rewrite 1 as 2 over 2, 3 over 3, 4 over 4, 5 over 5. Anything over itself is 1. So in this case, because I want a denominator of 4, I can rewrite 1 as 4 over 4. Okay? Now, if that hurt your brain in any way, you could look at that 1 as 1 over 1, and then you could think of it as, oh, we need a like denominator, so I'm going to multiply by 4 here and here. And that'll give me 4 over 4. Maybe that'll hurt your brain less if you didn't follow me the first time. So anyway, 4 minus 1 is 3, so that'll be 3/4. Okay, fine and dandy. So this will give me 5 to the 3/4 power. And this is the final answer. I don't really like that 4 very much. Beta. Okay, let's move on. Okay, it is time for problem number 8. Let's see. Oh goody. Notice that the bases are not the same, but the exponents are the same. If the exponents are the same, you can do the bases. You can do the thing with the bases. So since the exponents are the same, I can go ahead and multiply the bases. All right, 10 times 4 is 40. So I will have 40 to the 3/4 power. If the exponents are the same, you can do the bases. If the bases are the same, you can do the exponents. So yeah, keep all that in mind. So that means I have this to the 4th power. Now I have a power raised to a power. Now if you're me, if you're awesome like me, then you will just go ahead and cancel these right now and just go straight to your final answer of 40 to the 3rd power. Okay, and that's it. You're done. Now, if you are not on my level, which you cannot be blamed for, then you will multiply these first of all. Okay, you might even think, oh, this is 4 over 1. So this is going to be 40 to the 12 over 4 power. All right, 3 times 4, 4 times 1. And then you would reduce this. 12 divided by 4 is 3. And then you will arrive at my answer a step later. Okay, so hey, if you got to do this, do what you got to do. Do you? Let's do number 9. Oh goody, look at this. The exponents are all the same. If the exponents are the same, you can do the bases. So, starting with the numerator, since the exponents are the same, I can go ahead and multiply these bases and get 24 to the 2/3 power. So that's great. And that's over 3 to the 2/3 power. Again, since these exponents are the same, I can do the bases. And now I'm talking about dividing. 24 divided by 3 is 8. So I'll have 8 to the 2/3 power. Okay, now it's time to talk about something we haven't really talked about yet today. When you have a fractional exponent like this, it's sort of like this. If I have, in general, all right, these are like notes off to the side here. If I have x to the p over r power, this numerator, this p is the power, and this r is the root. So it's power over root. That's why I use p and r. So that means if r is the root, then that means I could write the r root of x, all right, because r is the root. Now if p is the power, that means I can write this with p as a power like that. So when you have a fractional exponent, you can really look at it as two separate things, a power and a root. It's usually easiest to do the root first and then do the power. So if I do that with my 8 over 2/3, okay, 2 is the power, 3 is the root. Start with the root. Then this would be like having the cube root of 8, all right, because 3 is the root. And then 2 is the power, so a power of 2. So this is what you would do. And we know that the cube root of 8 is 2. All right, and if we didn't know it, we have the chart. All right, the cube root of 8 is 2. And then, of course, finally we have 2 squared, which is 4. Okay, so the final answer is 4. So just remember, if you have a fractional exponent, if it's helpful, you can rewrite it as a root and a power, all right? The numerator is the power, the denominator is the root. Okay, here comes number 10. All right, dealing with the inside part first. It's probably helpful if you look at this as y to the 1 power. So the bases are the same. If the bases are the same, I can work with the exponents, which in this case means having y to the 1 plus 1/4 power, okay? When you multiply with exponents, you add the exponents, okay? And this is still there. So I've got 1 plus 1/4. Okay, so remember, just do this off to the side. Remember that if I have 1 plus 1/4, that's the same thing as 4 over 4 plus 1/4. So that's the same thing as 5/4. Okay, so that's what's happening right here. Okay, so that means I'm going to have y to the 5/4 power raised to the 4/3 power. Now again, if you're me and you're awesome, you are going to just cancel out these 4's. All right, because you had one high and one low. And that is going to immediately give you y to the 5/3 power. And that's your final answer. Now, if you're not me, or you're not on my level, then you might do this. And 5 times 4 is 20. And then 4 times 3 is 12. So you might do this at first. But then you have to reduce. So you might go, okay, both of these are divisible by 4. Hopefully you recognize that at least. So then that will then give you 5/3. Okay, so that would be the answer to number 10. All right. Now, number 11. Now I see that negative power, so I might wind up dropping that down later. But I will do that later. For now, I have a power to a power. I am simply going to multiply. So remember, this is like -3/1. So when you multiply these, you just multiply numerator times numerator, denominator times denominator. So this will be y to the -3/6 power. 3/6 is 1/2, so this will be y to the -1/2 power. Now we will do what we talked about. This is a negative exponent, and we know that if you have a negative exponent, that means this expression is on the wrong side of the fraction. So this is going to have to be dropped down. So if I do that, in the end, I will have 1 over y to the 1/2 power. So this would be your final answer. All right, for number 11. Okay, this brings us to number 12. If the bases are the same, we can do the exponents. So in this case, that means add the exponents. So I have 1/3 plus 1/5. Once again, okay, off to the side, if I want to do 1/3 plus 1/5, I need like denominators. All right, let's see. Let's turn these both into 15s. So if I multiply this by 5, okay, got to do the top two, that'll make 15. If I multiply this by 3, I'll get another 15. Got to do the top two. So this will become 5/15, okay, plus 3/15. All right, that means 8/15. Okay, that's how you add fractions. So that is what is happening here. So I will have x to the 8/15 power. All right, and that is the final answer. All right. All right, now we're at number 13. Wow, there's really, these problems seem to be getting easier and easier. For this one, there's really nothing else to do other than the fact that this has a negative exponent, and we know that any expression with a negative exponent is on the wrong side of the fraction. So this is going to have to be moved up. So once this moves up, then we will have x to the 5/4 power. And that's it. So that's the answer, number 13. Okay, number 14. If the bases are the same, then we can do the exponents. So the bases are the same. So that means we can go ahead and do x to the, now when you're dividing, you subtract the exponents. So we have to do 3/7 minus 1/3. Okay, so once again, off to the side somewhere, we can do this calculation. So 3/7 minus 1/3. We need like denominators to make this happen. We'll turn both of these into 21. So I'll multiply this by 3, top and bottom, and I will multiply this by 7, top and bottom. So that is going to give me 9/21 minus 7/21. Okay? 9 minus 7 is 2, so I have 2/21. Let's see, how much space do I have? So that is what is happening right here. All right, so this is going to be x to the 2/21 power, and that's really all there is to that. So that's the end of number 14. Okay, wow, now we have different variables and things happening. Let's see, what are we going to do? Well, let's do this. First of all, let's deal with this negative exponent. You know that if you have a negative exponent, then that variable is on the wrong side of the fraction. So this is going to have to move up. So on the next step, this is what I'm going to have. Alright, so I still have x to the 5/3 power, and I still have y, okay, that's sitting there, and I still have this x down here, but now I have this y to the 1/2 power that's moving up, so I have y to the 1/2 power. So basically, just do the x's and the y's as almost like two separate problems. So as you look at this, think of this x as x to the 1 power, and think of this y as y to the 1 power. Okay? So when we go to do the x's, this is what we're going to do. All right? So I'm going to have some kind of an x, and I'm going to have some kind of a y. I just have to figure out what the powers are. Now, with the 5 over 3 and the 1, I'm going to subtract. All right? Because I'm dividing, and when you divide, you subtract the exponents. So, off to the side someplace, okay, I'm going to do my 5 over 3 minus 1. Okay, because I'm subtracting these. So that's going to be 5 over 3 minus 3 over 3, because 3 over 3 is 1. So that's 5 minus 3 is 2, so that'll be 2/3. Okay, 2/3. So that's why I'm going to have, on the x here, I'm going to have x to the 2/3 power. All right, now let's do the y's. Now here I have y to the 1 and y to the 1/2. What am I going to do with these exponents? I'm going to add. So I'm going to do 1 plus 1/2, all right? Because when you multiply, you add the exponents. So this is 2 over 2 plus 1 over 2. So that is 3 over 2. Okay, so that is what's happening here. So that's why I will have y to the 3 over 2 power. All right, and that is it. All right, that's the final answer for number 15. All right, man, this looks ugly. Let's see. Let's just take it one step at a time. First of all, the negative exponent. All right, if you see a negative exponent, that means that variable is on the wrong side of the fraction. So I'm going to wind up dropping this down. So if I do that, then let's see what we have. Everything else stays where it is. So I have x to the 3/4 power still. I still have y sitting there. Down here, I still have x to the 1/4 power. And I have z to the 2/3 power. Whoa, I messed up my z. I say I have z to the 2/3 power. But now this dropped down to the denominator. So I'll have z to the 1/3 power in the bottom. Okay? Now I can start trying to put these things together. So I'm going to do the x's and the y's and the z's, sort of like three separate problems. So let's start with the x's. So in fact, okay, I know I'm going to wind up with an x and a y and a z. All right, so I'm just going to set those up. It just depends on what the exponents are going to be. So first of all, the x's. Again, when you divide, you subtract these exponents. So off to the side, I'm doing 3/4 minus 1/4. Okay, well, 3/4 minus 1/4 is 2/4. But that simplifies down to 1/2. Okay, so we have x to the 1/2 power. Okay, and that came from this. Now the y it's the only y. So the y is just going to stay y. Now the z's. You know what? I should be careful. These z's are all in the denominator. So whatever happens when I add these exponents, it's going to be in the denominator. So I really never should have written this z right here. I should have written the z down here, okay, because they're all in the denominator. Okay, so I have to add these exponents. So 2/3 plus 1/3, okay, maybe I'll just do this off to the side. So I'm doing my 2/3 plus 1/3. Well, that's 3/3, which is just 1. Okay, so this is like having z to the 1 power, but I don't really need to put the 1. So that means this is the final answer. All right, that is the final answer for number 16. Okay, let's take a look at number 17. What happened to the easy problems that we had before? Let's see, is there anything I can do inside? No. So, when you have power raised to a power, you multiply. So I'm going to wind up multiplying all of these things. So this is going to give me, let's see, a, and remember this is like -5/1. So this is going to give me -15, it's 3 times -5, over 4. And I'll have b, and again I'm just multiplying, so this will be -5 over 2. Alright, that's what I have over here so far. Okay, now I'm going to do the same thing over here. 1/8 times 2, -2. So this will be a to the -2 over 8 power. Okay, and I will have b to the 3 over 8 power. Because remember, this is like 3 over 1. So 3 times 1, 1 times 8. That's 3 over 8 power. Okay, so this is what I have. All right, Javis, just wait for that bell before you go. Okay, so now I just need to put these things together. Now, of course, 2 over 8 is 1/4. Okay, so I'm just going to go ahead and simplify this. And this will be the 1/4 power. Okay, so now, putting the a's together. Since we're multiplying, we add these exponents. Alright, so when I go to put the a's together, alright, I'm doing these guys right here. Then what I'm doing is I'm doing a to the, and I'm adding these exponents. So I'm doing -15 over 4 plus -1 over 4. Okay, I'm putting those together for the a's. When I put the b's together, it's the same type of thing. Alright, so when I put these b's together right here, then I'm doing b to the, and I'm adding these exponents. So I'm doing -5 over 2 plus 3 over 8. So that's what's happening. So I just need to do this addition. So as far as the a's, I'm going to have a to the, look, -15 and -1 make -16. So I've got -16 over 4. Okay, now that's going to reduce down to -4. -16 divided by 4 is -4. So I've got a to the -4 power. Now, when I go to add these guys, I need to have like denominators. So, I'm multiplying by 2. I better do this off to the side. Okay, so what is happening is I have negative 5 over 2 plus 3 over 8. If I multiply these by 4, then that will give me a denominator of 8. So let's imagine that we do that. So let's multiply the numerator and denominator by 4. Okay, so that is going to give me negative 20 over 8 plus 3 over 8. Well, negative 20 plus 3 is negative 17, so that is negative 17 over 8. Okay, so that is what I'm going to have here on these b's. So I've got, so I've got b to the negative 17 over 8. So I'll just pull that down here. So b to the negative 17 over 8 power. Now look, both of these have negative exponents. So all that's left to do is to drop these down to the denominator. Okay, do you understand what I'm saying? So this is the invisible fraction line. Both of these have to drop down. So that's why the final answer will be 1 over 8 to the 4th power b to the 17 over 8 power. And that is it for number 17. All right, let's go on to number 18. All right, let's simplify what we can on the inside of number 18. I see these g's, so I have like bases. So when you have like bases, you can work with the exponents. In this case, I can subtract. So what I'm doing is, with the g's, I'm doing g, let me make this a little thinner. I'm doing g to the 2 over 7 minus 5 over 7 power. Alright, I'm subtracting. And then I will still have this h to the 1 over 7 power. And all of this will still be to the negative 3 power. But right now I'm doing this subtraction. So of course 2 over 7 minus 5 over 7. 2 minus 5 is negative 3. So that is going to give me g to the negative 3 over 7 power. And then I still have my h to the 1 over 7 power. All to the negative 3 power. Okay, so I'm going to go ahead and do the negative 3 power to everything, which in this case means multiplying. A power to a power you multiply. So if I multiply negative 3, that's going to give me g to the positive 9 over 7 power. Okay, negative times negative is a positive, and I'm really doing, I'm thinking of negative 3 over 1. So negative 3 times negative 3 is positive 9. 7 times 1 is 7. Similarly, I will have h to the negative 3 over 7 power. 1 times negative 3 is negative 3. 7 times 1 is 7. Okay, so that's what I did there. Now, of course, anything with a negative exponent is on the wrong side of the fraction. So this expression right here, the h, is on the wrong side of the invisible fraction. So I'm going to have to drop it down. And that's why my final answer is going to be So I'll have my g to the 9 over 7 power over h to the 3 over 7 power, because I had to drop it down. So this is the final answer for number 18. Alright, on this problem, because we have these two parts, the first thing we should do is multiply all this together and make it into one problem. So 3 times 15, that's 45. And then we have the r to the 3rd power out there. So that's the part in the front. Now underneath the radical, and let's not forget that it is the 5th root, I need to do 64 times 1024. So let's see, 64, let me clear this out. 64 times 1024. Alright, so that's 65,536. 65536. Alright, and then we have, let's see, r to the 12th power times r squared. That's going to be r to the 14th power. S to the 9th times s to the 6th will be s to the 15th power. Now we've made it all into one problem. So the next step is to break this up into the part that we can reduce and bring out, and the part that will be stuck on the inside. Now first of all, this part in the front is just going to stay out front. Alright, so I've got this 45 r to the 3rd power. That's just going to be waiting around for later. Now, but the radical part. Alright, let's prep the problem. Let's start with the 65,536. We're going to have to break that up into something that we can take the 5th root of times whatever's left over. So let's look at our exponent table. Alright, so our target is 65,536. We're trying to do the 5th root. So we're looking at this column right here. Okay? Alright, so the first number that has a chance. These numbers are too big. Alright? The number has to be less than half of this to have a chance of dividing in evenly. So let's start with the 32,768. So I'm going to try dividing this thing by 32,768. Alright, so here I've typed this into my calculator, and let's see what happens. Okay, that went in perfectly. 2 times, no decimal. That means that this is the number I'm going to use, 32,768, the number off of the chart. And don't forget that it went in twice. Okay, so when I split this up, the first thing I'm going to have is that 32,768. And then that is times 2. Okay, just going to double check. Yeah, 32,768, and it went in twice. Okay, that brings us to the r to the 14th power. I need something that is divisible by 5. The biggest number under 14 that is divisible by 5 is 10. So I'm going to split this up as r to the 10th power, and since I started with 14, that means I'm going to have 4 r's left over. So I'll split this up as r to the 10th and r to the 4th. Now, s to the 15th power, 15 is already divisible by 5. So this is ready to go just the way it is. So I'm just going to write down s to the 15th power just like it is. So look, everything in red here under the radical has an even 5th root. So I'm going to take the 5th root, and these numbers will simplify and come out of the radical. So let's start with the 5th root of 32,768. Okay, so we're looking at this number right here. Alright, so look, the 5th root of 32,768 is 8. Okay, so this is going to come out and become 8. Now the 5th root of r to the 10th power is going to be r squared. Alright, because 10 divided by 5 is 2. And then s to the 15th power is going to simplify down to s to the 3rd power. Okay, once you take the 5th root, because 15 divided by 5 is 3. So that takes care of each of my red things. Okay, now the black part is the part that's going to be left behind. So I'm going to still have the 5th root. So I've got 2 and r to the 4th power that will be left in here. So there's my 2, and there's my r to the 4th power. Okay, now I've got 45 r to the 3rd power waiting out front. I'm just going to bring that down. Alright, 45 r to the 3rd power. And so this will simply be multiplied by the rest of it. So that'll really be my last step when I do that multiplication. So let's see, 45 times 8, I don't know that off the top of my head. 45 times 8. That's 360. Okay, so I've got 360. And then r to the 3rd power times r squared is r to the 5th power. Okay, and then I've just got this s to the 3rd power to bring down. Alright, and then I've got the radical. So that's the 5th root of 2r to the 4th power. And this is the final answer. Okay, this is the last problem on the worksheet. So I've got this numerator, I'll deal with that later. But now the denominator, I've got 2 expressions in the denominator, so I'm going to go ahead and put these together. Since the roots are the same, I can go ahead and multiply like I normally would if the roots weren't there. So like I said, in the numerator we have the cube root of qr squared. Alright, I just copied it. Now in the denominator, I'm going to put this together in one expression. So first of all, the q's, q to the 3rd power. Well, there is no q over here, so I'm just going to copy that down. Q to the 3rd power. Okay, now the r's. R to the 7th times r to the 5th. That is r to the 12th power. Okay, 7 plus 5. And now similarly the s's. Alright, this will be s to the 17th power because 9 plus 8 is 17. So far I have this. Now, again, since the 2 radicals have the same root, they're both root 3, then I can divide like I normally would. So I'm going to ignore the fact that these are in radicals and just cancel things out like I always would. So if I have a q in the top and 3 q's in the bottom, I'm going to do some canceling, and this is going to be, let's see if I can fit this. So cube root. Alright, so I'm going to have q squared down here. I'm going to have q squared. And in my mind, I'm hoping you see what I'm doing here, but just in case you can't, then I looked at this. I have q over q to the third power, right? That means q over q, q, q. So all I did was I canceled out one of the q's. So that left two q's in the bottom. So that's why I have q squared down here in the bottom. Similarly, look at the r's. I have these two r's in the numerator will cancel out two of these r's in the denominator, and that's going to leave r to the 10th power. And also I still have these s's. So I have s to the 17th power. Now, all the q's in the top canceled out and all the r's canceled out. So the only thing I'm going to have up here is a 1. So I'm almost done, except for I need to continue to simplify my r's and my s's. I can't do anything with the q's. All right, 2 is already less than 3, so there's no way I'm going to get anything that's divisible by 3. 10 is not divisible by 3. However, what I can do is I can split that up. Okay, so I will do this. So I will have the cube root, and I've got my q squared, but r, I can split up r to the 10th power as r to the 9th power and with one extra r. Okay, for a total of 10. Why 9? I wanted something divisible by 3, so I picked the first number under 10 that would divide by 3. Doing the same thing with the s to the 17th power. What's the first number under 17 that is divisible by 3? 15. So I will put s to the 15th power, and how many s's are left over? So I will then have s squared, all right, for a total of 17 still. Okay, so these two things that I've now shown here in pink will reduce, and I can write them outside of the radical. So what I'm going to have in the end, and this is going to be the final answer, okay, I'm going to have 1 over, and let me do the pink stuff first. So r to the 9th power, because I'm dividing by 3 here, I'm going to get r to the 3rd power. S to the 15th power, once I do the cube root, is going to become s to the 5th power. All right, 15 divided by 3. And everything here in blue is going to be stuck on the inside. So I will have the cube root of q squared r s squared. So this will be our final answer. Okay, and that is the answer for number 20. All right, and also that is it. That's the end of this lesson. That was the last problem. So I hope this was helpful to you, and I hope that you watched this without a pencil in your hand so you can learn, go back and do it yourself. If you can do all of these problems on your own without copying, then you are understanding this topic, and we'll call that Burton style. Okay, I will see you on the next video.